Let's take yet another example and let's see how we can possibly evaluate the example. Right, example 2. Let's say I have that y is equal to, let's make it more complex now in this case. Let's say I have 3x to the power 3 minus 2x squared plus 4x minus 5. Let's say I'm asked to find the y over the x here. Basically, I'm seeing y, I'm seeing x's here, several x. So it becomes I'm representing y with respect to x. That's the concept. So we said that I'm representing y with respect to x. That becomes what? The y over the x. Now I'm seeing 3x cubed, a term. I'm seeing 2x squared, a term on its own. I'm seeing 4x, a term on its own. And I'm seeing 5. Let's differentiate each term one after the other. If I'm seeing 3x cubed, we said the key concept is that what's the power here? 3. We said multiply by the power, that becomes 3. This 3 first times, all the question here was 3x cubed. We said subtract 1 from the power. So I have this. So I'm done evaluating 3x cubed. Move to the next one. I have a minus sign, minus. What's the power here? The power there is 2, becomes 2 times, what's the question here? 2x squared. We said subtract 1 from the power as established earlier before now. Also, this is a plus sign here, plus. I'm having 4x. If I have a 4x this way, what's the power above x here? Of course, there's an invisible 1 from the power there. So there's an invisible 1 here. So let me just attach it here. There's an invisible 1 there. So whenever a term stand alone, the power is always raised to power. Is always raised to 1. Right? So the power here is 1. That becomes 1 times everything here is what? 4x to power what? This is 1. Then it says subtract 1 minus 1. Right? So the power here is 1. It becomes 1 times what I'm having here. Then subtract 1 from the power. Finally, I can see minus 5. It becomes minus. This is 5. Becomes 0. Why is 5 0? Note that when it comes to differentiation, 5 here is assumed as a constant term. A constant term is simply a term that does not have x. This 5 now does not have x. It refers to as a constant term. So whenever you differentiate a constant term, it's always 0. Please note that whenever you differentiate a constant term, it's always 0. If I differentiate 5 here, I'll have